Bismillah ar-Rahman ar-Rahim. So this is chapter 3. The title is Vectors. Most of it will be a review for you because I assume that you are familiar with all of that. The first one is the Cartesian coordinate system. Consists of x-axis, y-axis, and the way we write the points, we start with the x coordinates and then the y coordinate. So for example, a point 5 and 3 means 5 units in the x-axis and 3 units in the y-axis. This unit, for example, it's minus 3 units in the x-axis and 4 units in the y-axis. 1, 2, 3, 4. Very simple. The polar coordinate system, even if you heard about it the first time, we all use it. It's very simple. We have our origin. The 0 is our origin. And we need two things in this system. First of all, we need the length of our vector. The length of our vector, we call it R or A or whatever. By the way, this is vector R. And this is magnitude of vector R. When we don't put the sign, it's just we are talking about the magnitude. So here, let me enlarge it a little. We have the magnitude in the polar coordinate system. We need the magnitude, we need the origin, and we need an xy point. We need an xy point. And the relation, and you should familiarize yourself with that, should be like your name, no hesitation at all. We have R, if we have, for example, a vector R, the x component of that vector is the length R cosine theta. The y component is the length of that vector R sine theta. And we know that tan theta must equal y over x, which is sine theta over cosine theta. These three lines, you should know them as your name. And no hesitation in the exam, because if you know those three lines, then the exam sometimes is confusing, so you don't need to confuse yourself more than that. So make sure you know them very well. The length of R, if we know the x component and the y component, is equal x component square plus y component square. It will give me the length of my vector. Let's try to solve this example. Cartesian coordinates of a point in the xy plane are, and he gave us the coordinates as shown in the figure, and the unit is meter. Whoops. Find the polar coordinates for this point. That means we need to find R, the length of that vector, and we need to find, he gave us the xy component, so we need to find theta. We need to find theta. Well, just straightforward. And in this example, you need just to be careful about one point. I will mention it here. Straightforward. The length of R is x squared plus y squared. It will give you 4.3 meter. And here is the point. Tan theta is equal y over x. So if I just use my calculator, just to show you, is there enough light? Okay, so it's minus 2.5 divided by minus 3.5. So it's 5 over 7. Tan inverse what's the number? It's given me 35.5. So theta in the calculator, 35.5 degree, 36 degree. So how did he get this answer? So this answer is 180 plus 36. That's 180 plus 36. And how did I know? Well, because I know the coordinates in my system. The x-axis is negative and the y-axis is negative. So that means I must have my theta in this quarter. So this is positive x, positive y. Here it's negative, it's positive x and negative y. Here negative x, negative y, and here negative y, positive x, and negative y.
Doctor, second one is...
Yep, I saw it. Minus x minus x plus y. So although you put in the calculator the numbers and you get 36, however, if both coordinates are positive, that means in this quarter, x is negative, y is positive in this quarter, both negative in this quarter, and here positive x and minus y in this quarter.
Doctor.
نعم تفضل.
Can you kindly give us, I remember we got in high school that specific rules for each quarter to find the theta.
I just did. You look at the x-axis, the x component and y component.
Yeah, I know. I mean, now we knew it's in the third quarter. So what to do next? We added 180. What if it was in the fourth quarter? What do we do?
You add 270.
Okay, those rules that I'm talking
yeah,
about.
Yeah,
Can you,
it's
give us, like,
well,
review?
yeah, well, we call it rules, but it's because you are a high school student. You don't need to memorize any rules. The only thing that you need to memorize is this. If it is positive and positive in this quarter, etc. And then
can you help us to understand the rules instead of memorizing them?
I just did. You don't need to memorize anything.
Okay,
okay.
Let's say I didn't memorize and I got a point in the fourth quarter and I had 270, but how did I get that 270?
لأنه we have positive x and negative y. Let me draw this. This is y, this is x. Now your coordinates of R was positive X and negative Y. Which quarter? I never used that function. Muhammad Saeed asked, there is a polar function. Wallah, I never used it. So use it at your own risk. Use it at your own risk. So, were you with me when I said the Cartesian coordinates? We write X and Y. So what's the value if we have a point here? What should be the X, positive or negative? طب Y? That's it. That's it. So if we have a point, opposite is always Y. مش فاهم عليك يا حمد.
دكتور في لزوم؟
في لزوم لشو؟
لا برويك شنو أقصد دكتور.
opposite is all. والله مش فاهم عليك. احنا حكينا
دكتور أنا أقصد مش مفروض مقابل على مجاور؟
يعني ما تدخل في هاي المتاهات. It's much simpler than that. ايش المقابل وايش المجاور؟ We didn't mention that. يعني no need. What you need to remember is those 3 rules. بدك تسميهم مقابل ومجاور ووتر وانت حر. But what you need to know is just those 3 rules. And you need to know them like your name. If we have a vector R, the x component of that vector is R cosine theta, the y component is R sine theta, and the tan is y over x. Once you know those, خلاص, you don't need مقابل or مجاور or water or which quarter you are in. Well, it depends on the value of x and value of y, the sine of x and the sine of y. So it's clearly, if you have something positive x and negative y, it should be here. Should be here. Why? Because, well, this is the positive axis, this is the negative axis. Positive y, negative y. So when I say positive x, negative y, positive x, negative y. It's much simpler than that. You don't need to memorize 10 rules. What you need to memorize is this. And without doubt, because you will face doubt in the exam. لا, negative angle, no. In the polar system, you need to write the right angle. No. You start from 0. You start from the x-axis. The positive is the axis. So it's relative to the positive x-axis. Positive is, its angles are positive with relative to positive x-axis. That's the thing. I'm telling you that because sometimes in the multiple choice, you will not find the minus 144. So just to make things clear. Time. Okay, Yusuf Ali. if I give you the y-axis and the x-axis, and it's 0.714, what's the theta when you put your calculator, when you use your calculator? Theta will be 36 on the calculator. But in reality, we know because x is negative and y is negative, it should be in this quarter. So how to transfer your angle from 36 to this quarter? You add 180 to the angle.
Doctor,
تفضل.
if it was in the first quarter, we will add the 270?
First quarter is this one يا شيخ.
The fourth.
هذا first quarter, هذا second, هذا third, هذا fourth. Yes, you add 270.
Okay, thank you.
Because you need your angle to be here in this quarter. So then you add 270. طيب. Vector and scalar quantities. Scalar quantity is completely specified by a single value with an appropriate unit and has no direction. You know that. Now, a vector quantity is completely specified by a number with an appropriate units. That's the magnitude of the vector plus a direction. Plus a direction. So here, an object is moving in arbitrary path. However, no matter what is the path, no matter what distance he is traveling, the displacement is from the first point is the vector. It's from A, the starting point, to B, the end point. So it has a magnitude and it has a direction. That's the displacement. The distance, well, the distance, it's just going through this path or any random path. But if we want to talk about the displacement, it's from point A to point B. طيب. Let's clear this mystery. In the book, he said a vector A is equal to vector B only if the length of A is equal to the length of B and both point in the same direction along parallel lines. So vector A and vector B, they are equal. First of all, they have to have the same length. Second, they have to point in the same direction. Like this one, same direction. In parallel lines, and they have to be all parallel. Clear? خلاص ممتاز. Because sometimes the way he identify things or define things, sometimes it's a little bit confusing. A and B are two vectors. They have to have the same direction along parallel lines, and they have the same to have the same length. In other words, theta and r are the same. Yep. Theta and length are the same. طيب, how we can add two vectors? How we can add two vectors? Now look at the notation. This is important. when I say vector A plus vector B, that is, for example, vector C. All vectors. Now, A plus B is not equal at all to vector A plus vector B. Clear, yeah? طيب, what is the point? The point, يا جماعة الخير, إنه this addition is different than this addition. They are the same symbol, but A plus B is a number addition. However, here, vector A plus vector B, it's a vector addition. So they are not the same. Clear? Here, it's an addition, number addition. Here, it's a vector addition. It's a vector addition. So when you write A plus B تساوي C, this is definitely not equal to C plus, to the vector C. Clear? So addition here, it's not the normal addition that we know. It's not the normal addition we know. تفضل.
Do you mean that magnitude vector is not equal to the vector or something like that?
The magnitude of C, you mean?
Yeah.
That's a different story. I'm talking now about that you need to differentiate between the normal addition that you put on your calculator and the vector addition.
Okay.
You need to understand that. So when I write a plus, that's not the plus in the calculator. This plus, it's more like an operator that operate on vectors. And this plus, the one for vectors, it's literally, if we have two vectors, we bring vector B, the tail of vector B, we bring it on the head of vector A, and then we draw a line from the starting point to the end point. That's the plus when we add vectors. If we have three vectors, for example, A plus B plus C, vector A, tail of vector B at head of vector A, tail of vector C at head of vector B, and then we draw a line. And here, let me show you a vector addition. Just bear with me. And let me just adjust the screen so we can see it. Enlarge it a little. Yes. So, we have a vector V1. It's a vector v1. And we have a vector v2. Okay, so what is v1 plus v2? Well, literally, I just bring vector v2 and put it tail of vector v2 on a head of vector v1. And then the sum is from the first tail to the last head. So I can bring v2 to v1, or I can keep it as before, as original. And I can bring v1 tail to v2 head, and it will give me the same result. That's correct, because a vector has a direction and a magnitude, and if the direction and magnitude is fixed, no matter what you do, it will be the same vector. If I bring it here, I bring it there, I bring it there, it's the same vector. It's the same vector. But this is addition. Literally, we do that when we add vectors. Head to tail, and then from first tail to last head. Clear? This is how we add vectors in reality. You need to understand this, that when you add a vector, in reality, we just move the vectors, organize them, head to tail, head to tail, head to tail, and then the first tail to the last head. That's what we do when we add vectors. So it's not a normal addition. Clear? It's important that you understand it. Remember when we talk about finding the acceleration or finding the velocity or finding the displacement, basically we are just finding the slope. So if we have the displacement versus time, find the slope, you will find the velocity. If you want the acceleration, then you draw your graph, velocity versus time, and you find the slope. طيب, why we don't do all our calculations like that? You draw a graph, find the slope, because it's lengthy. It's lengthy. We just derive the equation. Deriving the equation is like finding the slope. But in reality, it's just finding the slope. And when you go backward, acceleration to velocity, you just integrate. What is integration? Find the area. And if you have v versus t, and you want to find the displacement, integrate. What's integration? Find the area. You need to understand, you need to connect to that. طيب, why we just do integrate and differentiate? Because it's much faster. But in reality, it's just a graph, finding area and finding slope. Now, in adding vectors, we are just literally reorganizing the vectors, and then finally finding from the first tail to the last head. I can do it like this, or I can bring this vector in here. It will give me the same addition. Clear? If I have more than one vector, it's okay. I will just repeat the same situation. Tail to head until the first tail to last head. Clear? طيب. If that is clear, then I will answer your friend's question. He said, is there another way besides drawing? Yes, there is. Yes, there is. So let me just reset this file. I will close it, open it again to answer your friend's question. Bear with me. So we said this is V1 and this is V2. طيب, is there any way to add two vectors without the graph? Yes. So we have V1 components. So this is V1x and V1y. We have the components of the vector. How? We just explain it. Vx is V cosine theta, Vy is V sine theta. So I have the values, the components of the vector. And I have V2, and I have the components of V2. That's correct, Adil. You need the angle, or the vector will be written in such a way that you know the x-axis and the y-axis. We'll come to that. We'll come to that. Okay, so now when I add the x components together. So this is the first x component plus the second x component. And I add the Vy component. So this is the first Vy component, and this is the second Vy component, and I have a new vector. So this is, I can find the addition of my vector using numbers without the need to draw my vector. Without the need to draw my vector. So I will just hide it. Maybe we'll use it again. So, because we were talking about that, here is a vector A. How we can write a vector A without without the need to know the angle? Well, suppose A is equal 3x plus, for example, 2y. So that means 3 units in the x, 2 units in the y. طيب, what's the standard? How we can write this in a standard format? We just write 3i plus 2j. And we will come to that. What is I and what is j? We will come to that. But when I write my vector like this, I know that it's 3 units in the x-axis and 2 units in the y-axis. We'll come to that just shortly. So A plus B is equal B plus A. We saw it in the graph. A plus B plus C alone is equal to A plus B plus C. A plus B alone plus C. It's the same, and we saw it also in the graph. No matter if I add A plus B or B plus A, it's the same. It's the same. Again, this is not the calculator addition. The plus is not the calculator addition. That is vector addition. Be careful for that. We explained this on the file. Okay. Now, what is A minus B? What is A minus B? Well, A minus B, its addition vector addition, but I add minus b. I don't add a b, I add minus b. So, for example, this is A. We said 3i plus 2j. And this is B. Let's say B is what? 4i plus 5j. So A plus B, I add the I together and the j together. So 3 plus 4 in the I direction, plus 5 plus 2 in the j direction. So that is equal 12i plus 7j. That's addition. Type subtraction, well, vector A minus vector B is nothing but vector A plus minus vector B. So minus vector B is equal minus 4i minus 5j. So A minus B. Now I add also. So 3 plus minus 4 in the I plus 2 plus minus 5 in the j. That is minus I minus 3j. أحسنت يا يمان. Very fast, very clever. أحسنت يا يمان. So subtracting a vector is nothing but adding the negative of the second vector. 7i, it's 3 minus 4 يا شيخ Khalifa. 3 minus 4, so that's minus 1. No, you have to write it as minus I minus 3j. Ah, you mean this one? Yeah, you are correct. Yes, Salman, ahsant. This one. 7. I went to 3 multiplied by 4. No, it's 7. Shukran, Khalifa. طيب, what else do we have? Component of a vector, we just mentioned that. Those are the 3 lines that you need to know them, memorize them like your name without confusion. Because you will be confused enough in the exam, so at least those you know without any confusion. This graph is exactly, but he filled it with words. This one exactly like the one we mentioned here. In the first quarter plus plus, second quarter minus plus, third quarter minus minus, and fourth quarter plus minus. And you don't memorize that, it's common sense. It's common sense because you have positive x-axis and you have negative x-axis. So here, he's explaining this thing. Explaining that. Correct. طيب, so far we were تجري الرياح بما لا تشتهي السفن. Software update. I hope it will not force me to do the update. Anyway, cross your fingers. Okay, so far we were dealing with 2 dimensions, x and y. But real space around us is 3 dimensions, x, y, and z. X, y, and z. So in our vectors, when we write them, remember when I told you we can write the vector as 3x plus 2y, they had a better convention is to use the unit vectors I, j, and k instead of writing x and y and z. طيب, what are those unit vectors? Well, from its name. Unit vector, that means it's 1. 1. 1 what? Well, depend on the unit I'm using my x and y and z. So if my graph, أهلا وسهلا بذكر الله. So if I am graphing, for example, meter, distance as a meter, so what will be I and j and k unit? It will be meter. So if x is meter, z is meter, y is meter, then I is equal 1 meter in the x-axis, j will be 1 meter, okay, will be also 1 meter. طيب, suppose that I'm drawing meter and here second and here centimeter. Now let me just use coloring. It will be clearer. So now x will stay as meter, z it will be time, and y will be centimeter. So now my I will be 1 meter, my j will be 1 second, and my k will be 1 centimeter. Clear? That's a unit vector.
دكتور
تفضل.
اللي هي العلامات اللي فوق الحروف كأنها
العلامات اللي فوق الحروف هذه y و x، هاي x y z.
قصدي فوق كل حرف الكي مثلا والاي والجي فوق.
هذا عشان this is how we write I. It's an indication that it's a vector in the x-axis. يعني we don't write I like this. Somebody will think it's just the I letter or J letter. We always write it I, and we put that is a unit vector. That is a unit vector. الحين sometimes when we do mathematics and we need to go fast, sometimes we can ignore it. The cap. But we are learning now, so the proper way to write the unit vector is to put a cap on the head of the letter. That means it's a unit vector. It is pointing in the x-axis. Do I switch K and J? Yes, I did. Thank you so much. مين هذا الشاطر؟ والله إنك رهيب. داود. شكرا يا داود. أنت رهيب يا داود. That's centimeter and K is second. Thank you so much, Dawood. Clear? That's a unit vector. It's the magnitude of that vector is 1, and it is pointing, I is pointing in the x-axis, J is pointing in the y-axis, K is pointing in the z-axis. No, that's arbitrary units, Adil. Just arbitrary units. Suppose that in our graph we have meter versus second versus centimeter. Suppose. Then the unit vector will be 1 centimeter or 1 second. It's just to illustrate them. It's just arbitrary, so you can know what is a unit vector. طيب, once we define the unit vector, then we can write A as I did a while ago. The component of A in the x-axis and the component of y in the y-axis. And this is the proper way to write our vector. This is the proper way to write our vector. طيب, we come back to the polar system. Well, we need the length of our vector. Let me just enlarge it. تفضل.
الصراحة أنا ما فهمتش الأس، يعني حاولت أفهمها.
second.
إزاي يونت فيكتور بالسكند؟ يعني المفروض مش لف.
يونت فيكتور بياخذ اليونت تبع الاكسس. اذا كان كيلوغرام بصير 1 كيلوغرام، اذا كان سنتيمتر بصير 1 سنتيمتر، اذا كان تايم بصير 1 سكند، اذا كان velocity متر بير سكند بصير 1 متر بير سكند، اذا كان acceleration الاكسس بصير اليونت فيكتور متر بير سكند سكوير.
اوكي، طب ازاي يكون عندنا جراف فيه متر؟
لا ما it's not a real physical graph. It's just to illustrate for you that the unit vector, it is 1 and it will take a unit of the axis. يعني it's just imaginary to explain. يعني ال x versus z. طب ما احنا اخذنا انه لما يكون عندنا displacement versus time السلوب تبعها هو الفيلوسيتي. ليش يعني متعقد انه يكون عندك mass versus distance versus time؟ بيعقد؟ يعني ما بيعقد، لانه احنا كل الرسمات تبعتنا لما كنا نعمل الديسبليسمنت، ايوه x versus t، هذا متر وهذا سكند. صحيح؟ هلا احنا هون y versus x، هون x versus z. فلو كان عندنا فعلا x versus z، m versus distance versus or displacement versus time، واخذنا السلوب بعطينا الفيلوسيتي. y versus z سنتيمتر versus time برضو بعطينا السلوب، بعطينا الفيلوسيتي. أن الزمن كمية تعتمد على اتجاه يعني متجه. من هاي الناحية لا، احنا ما غطينا. صحيح فهمت اللبس تبعك. التايم احنا بنعتبره كوانتيتي، بس أنا اللي بحكي على التايم بحكي على عشان to explain what's the meaning of a unit vector. Unit vector will take the value 1 and it will take the unit of the axis, if it is x or y or z. يعني you will have مثلا a problem in physics لأنه time is not a vector. صح. طب in mathematics there is no problem at all. يعني time cannot be considered as a vector in physics. طب وإذا رسمنا الرسمة in math مثلا, how to define the k? The k is 1. The k is 1 and the unit of k is time, is second in mathematics. In physics, لا, we have to be a little more specific لأنه whatever we draw, it has to be a vector. شكرا يا أحمد على هذا التوضيح. أعتقد إنه هيك انكشف الضباب. انكشف الضباب. يعني أنا أعطيتكم hypothetical mathematical example just to explain what is I, J, and K. However, in physics, it has to be a vector. That's correct. Again, polar coordinates, you need, this is our origin. You need to know the length of R and you need to know the angle. And then you can write your two vectors. This is the addition, and we just had an example about adding when I added 3 plus 4 as 12, and one of you smart guy told me that 3 plus 4 is 7. We just did it. This graph, I just explained it with Adobe Illustrator. And now we need to generalize, because all the work we did on 2 dimension, now we need to generalize on 3 dimension. On 3 dimensions. Suppose that we have a vector A, 3 dimension, it has 3 components, and a vector B, it has 3 components. Now what is R? R is A plus B. R is equal A plus B. How to calculate R? Well, now it can be done in real graphics. Like we can build a 3D model and we add the vectors as we did in the 2 dimension, but it will be much complicated because now we need to move the vector in the 3 dimension. So we go back to math, and math will save us. Math will save us. So R, we add the I components, we add the J components, and we add the K components. Okay. طيب, we want to know the length of R. Well, the length of R is the length of A plus the length of B. And how we can get it? Well, Rx square plus Ry square plus Rz square. Cosine theta x, cosine theta with the x-axis for the new vector, Rx over R. The cosine y theta, cosine theta with the y-axis, Ry over R, and cosine theta with the z-axis, Rz over R. Let's take an example. I think this is the last, yeah. Let's take an example. يلا, I need a volunteer from you. I plus J plus K. يلا, what's the values in I and J and K? I need a volunteer. أحسنت. 6, 2, and 9. يلا. Give me numbers for B. 1, 2, 3. ما شاء الله. 1, 2. هلا انتوا احرار جبتوا كله positive في الامتحان to be more confusing. For sure you will see negative. For sure you will see negative. طيب, let's do A plus B. I plus J plus K. Make it confusing. يلا. هاي خليها negative. يلا, ال I component is 6 plus 1, 2 minus 2, و 9 plus 3. معناته R is equal 7I plus 0J plus 12K. And we write it as 7I plus 12K. We don't have any J components, so it's a waste of ink to write 0J. طيب, يلا, cosine theta x. We need the length of R. خلينا نحسب first the length of R is equal 7 square plus 12 square under square root. What's this? Calculate it for me. It is 13.9. والله, somebody else to confirm. Yeah, I confirm it. Okay, now cosine theta x is equal. What's the component of x? 7 over 13.9. That means theta with the x-axis is equal what's theta x? It's 59.8 Don't forget to put the units. طيب cosine theta y is equal 0 over 13.9. So theta y mathematically it's 90 degrees, but physically does it have any meaning? It has no meaning لأنه ال y component is 0. The y component is 0. So physically it has no meaning because y is 0. Y component is 0. Cosine with the z-axis z doesn't exist. It's a 0. Is equal 12, 13.9. So what's that? 30.3 degree. تمام. So let's summarize. First of all, when we add two vectors, 2-dimension or 3-dimension, it is exactly like adding them graphically or in reality by bringing head to tail, organizing my vectors head to tail. شو يا أحمد؟ دكتور please upload chapter. طيب إن شاء الله يعني خليني أكمل، خليني summarize it. Adding vectors is exactly, if we do it in 2 or 3 dimension, just reorganizing my vectors to put them head to tail, and finally from the first tail to the last head. That's addition. We can do it in reality, physically. We can do it physically. So if we have the vectors as a physical component, we can just reorganize them head to tail, and the addition is from the first tail to the last head. طيب. This is the same equivalent of adding the x components together, the y components together, and the z components together. It's the same process. طيب, if it is the same process, why we use the calculation then? Well, because it's much faster, much easier, less confusing. شفنا in 2-dimension it's very easy to organize them. In 3-dimension, you have to be expert in AutoCAD or 3D the program in order to add them properly. So it is the same exact operation, but we do it by adding the x components together, the y components together, and the z components together. Clear? Now another important thing, in the addition of vectors, it's not the addition of numbers. It's a different process. We will face this soon when we go deeper in the course, that you'll be surprised that we don't have vector multiplications. We don't have vector multiplication as the one we have in numbers. we will learn that we will have dot product and cross product. There is nothing called multiplication with vectors. Either we have dot product or cross product. It's a different operator. Now, this is important also to know that this addition is not the addition that you put in your calculator. It's vector addition. You need to understand this. And I advise you to memorize the vector, 3 lines vector relation. Memorize it, it's very important. And you need to know it by heart, these 3 lines, as your name. So in the exam, you are not confused at all. You have a vector r, the x component is r cosine theta, the y component is r sine theta, and tan theta is equal y over x. Any other question? We are using sine. Here is sine. And here is cosine. If your question is on the last example, لأنه we need the angle with the x-axis, and here we need the angle with the y-axis, and here we need the angle with the z-axis. So you have to use a cosine. You have to use cosine because we need the angle with the x-axis. لأنه for 2 dimension is very easy to see. Here is x, here is y, and you have a vector. That's my vector. This is r. We need this angle. So for this angle, it's a cosine. Well, if you want to know this angle, then you use sine. But for this angle, you use cosine. In 2 dimension, it's very easy to imagine. So I suggest that you familiarize yourself in the 2 dimension, and once you have a strong hold there, you go for 3 dimension. You just automatically apply the same rule. You automatically apply the same rule once you convince yourself of the 2 dimension. Clear? طيب خلينا نوقف التسجيل. Let's stop recording.